Hi students, hope you have doing the good practice on your JEE Advanced, but these questions will give you the overall revision of entire organic chemistry. I just picked out top 15 questions to cover entire organic chemistry for JEE Advanced 2025. Okay, so let's get started with the first question. D and L configurations of above carbohydrate is. Okay, so usually in JEE Main, you might have seen the questions which is very simple, cis and trans, or you can see number of geometrical isomerism, it will exhibit geometrical isomerism or not, those type of questions. But in JEE Advanced, it's a bit different. They will ask you the questions from which were not asked in JEE Main. The unusual questions you can expect in JEE Advanced. Okay, so don't get scared. We can do that, right? You can easily do that. So here they are asking for DL configuration. So DL configuration we already know. If the last chiral carbon is having the OH group on the right side, then that is D. If that is on the left side, then that is L. Okay. So let's see here. All three is a different compound. I mean, the atoms or the groups attached are the same, the attachment point is different. Okay, so first what we have to do? The first thing first, you need to consider this position must have the oxidizing group like CHO. This position should have CHO here. Okay, so to that point we have to rotate it. I'm taking the first one, which is CH2OH, OH, H, OH, H, CHO. Correct. So I have to rotate in the way CHO, the oxidized one, must be on the top. Right. So if I am doing like that, this CH2OH will come down, and then what will happen to this OH and H? So OH, this OH goes here, right? Just to rotate it, just through the rotation. Okay, so this OH will go here and then H will go here, and this H and OH will come and occupy these two positions. Okay, now which is the chiral carbon over here? The last chiral carbon, that is this point, and the OH is on the left hand side, which means this is L configuration. Okay, so in the options you can see all are starts with L. Okay, so let's move on to the second molecule. So the second molecule, which is having CH2OH, HH, OH. Very simple, isn't it? So I'm just doing the rotation in the way the oxidized one, the CHO on the top. So H, OH, OH, and CH2OH. Here you can see once again the OH group which is on the right side, which means this is D configuration. So let's see the options. Either C and A are eliminated, so either B and D can be our answer. Okay, so let's move on to the third one, where I'm having CHO on the top, so no problem with that. So let me do that with the here. Let's try to do that, but you can see OH group is not in the bottom. So in that case, the second point you need to remember over here is, if I am doing the odd exchanges means one exchange or three exchange, five exchange, like not five exchange, one exchange, three exchange, like that. So in that case, the configuration will change. Right? If I'm doing the even exchange, the configuration remains the same. And what do you mean by that? Odd exchange, let's say I'm doing the exchange of OH and H. Just I'm changing the position of OH and H only. In that case, the configuration of that particular carbon will get changed. But if I am doing the even exchange, let's say after I'm doing this OH and H. Once again, I'm doing the configuration change of not this one here, because I want the CH2 OH group to be on the bottom like this. So what kind of molecule I'll get? I will get something, I'm just writing the bottom part, H and OH, isn't it? Two exchange I just made. So the configuration remains the same. Here you can see OH is in the left hand side, so which makes it is an L configuration. So answer to this question, which is the first one is L, second one D, third one L. So which makes LDL. So option B is the right answer to this question. Let's move on to the next question. Assign the double bond configurations to the following. Okay, cool. So what are the things we have? Here we have CH2OH, COOH, CN, CN, and the options given are E and Z. Fine. This problem you can solve it in a minute. Chemistry will give you more time because you already know about everything in JEE Mains. Okay, you might have read everything there, so don't miss out any question. Don't skip any part in chemistry until or unless you not at all know the reagent or not at all know the concept. Okay, this question, let's check it out. What is E? E, which is having the high priority groups or in the opposite side, right? And Z configuration, which is on the same side. Here you can see COOH and CH2OH, which is high priority. Obviously our COOH is our high priority, and you can see this side I'm having CH2, another side I'm having CH2. So I'm moving on to the next carbon. In this carbon I'm having a big group, but on this carbon I'm not having that group. Instead of that I'm having just two hydrogens, right? So which makes this as a high priority group. So which is on the opposite side. So this is E configuration. Then talking about this double bond, let me take the different color. Talking about this double bond, C and Cn are on the opposite side. You need not to find which is a high priority group. Of course this is high priority. Why I am saying like this? Because these are attached with carbon and hydrogen. Here I am having carbon with 3 nitrogens, because C triple bond N, no, 3 nitrogens I have to consider. So anyway, this is on the opposite side. Once again, the answer must be E. So E and E, option C is your right answer. Cool. Moving on to the next question. What steps is used to produce 1-chloro-3-ethyl benzene? Okay. So what is 1-chloro-3-ethyl benzene first of all? So these are the options given. So let me write 1-chloro-3-ethyl benzene. Okay. So benzene, 1-chloro-3-ethyl. Okay. So this is our target product. So let's see what are the options we have. The first one, all are related to electrophilic substitution. That is clear. Here I am having Lewis acid AlCl3, and then option C and D, which is having Friedel-Crafts alkylation, right? So which order I have to follow, which is our right answer? That is our question. In electrophilic substitution, there are few points to be noted. The first one is activating group and deactivating group, right? So the activating ones will direct the incoming electrophile to ortho and para position, and deactivating group will direct it to meta position. So that is our principle. So which is activating and which is deactivating, you already know about this, right? Activating means that we'll have R group in it, and then NH2. And one more exception is there, that is halogens. They are deactivating but direct the incoming electrophile to ortho and para positions. So these 3 points you need to know for electrophilic aromatic substitution. Okay, so let's see what we have. The first one, which is having RCOOH OCOR. So this group will be our electrophile, right? So which will get attached to the benzene ring, correct? So COCH3, and then with Cl2, COCH3, which is an orthopara directing or meta directing. That is meta directing. This deactivates the group COR. Okay, deactivates the group, meta directing. So incoming electrophile, which is that Cl plus 2 meta position. So we got COCH3 and Cl. And what about this reagent? Clemmensen reduction, right? Zinc amalgam with HCl, which will reduce this group to CO2CH3. Sorry, CH2, isn't it? So I got my product, right? I got my product. So let's see other options as well. This is our answer. Let's see other options as well. So option B, which says first Cl will get the position, and then Cl is an ortho directing. So whatever the group will come, that will go to ortho or para directing, which can't be our answer. The ethyl group will go to ortho or para position after Clemmensen. Then option D says first ethyl group, then Cl2, R group, which is ortho para directing once again. So obviously Cl2 will go to ortho and para. And option D says Cl2 first. So I told you it is deactivating, but still it will direct to ortho and para. So this will not give you the answer. So answer to this question is option A. Then the next question, which is 1R 3S cis 1 bromo 3 methyl cyclohexane. This is the name of the product. Sorry, reactant. This is the name of the reactant we have. Okay. Reacting with KOH and acetone to give the product. We have to find what is the product. Okay. So what we have to do? So first, let's observe what this KOH with acetone will do. Acetone is a non-polar solvent. KOH is the base. And I'm having the halo group. What is this reaction? Yes, correct. So that is SN2. So SN2 means, how the reaction will happen. So it will lead to the product of inversion in configuration, isn't it? So CH2Br is there, inversion in configuration. So only this part will get inverted. Very simple question, but you know what is happening over there. Then only you can answer these type of questions. Okay. So 1R, 3S, which is 1 bromo. This is 1 and this is 3. Correct? So the R will become yes because of inversion in configuration, and this remains the same. So 1 yes. So where is 1s in the options? Either option B or C will be our answer. Let's see the remaining also. Here I am having 3 yes. Okay, sorted. Cis or trans. See, the product will look like this. Product will go to the opposite position. Here I am having CH3 are above the plane and H is on below the plane. Here both are on the same side, so cis. But in the product I am having on the opposite side, which makes it trans. So answer to this question is option C. Is it clear? Very clear. Moving on to the next question. Compound C in the given reaction is. Okay. Here I am having tertiary OCl. Okay. Then NBS followed by KOH 1 1. What is C? That is the question. So what are the options we have? Let's see. So option A, B, C, D is given. It's not much changed over there, but what is the reaction can happen over there? Let's see. Let me write the reactant. And the first step, which is tertiary group with OCl H nu. So what is this type of reaction? H nu, light or sunlight. So this is free radical reaction, right? So free radical stability speaks more. So which free radical is much more stable? Tertiary, benzylic, right? So these are the free radicals will be much more stable. So here I am having either this free radical or this could also be possible. These two are the positions that can attack. The Cl group can attack. Correct. So which would be more favorable for the first step? Obviously this position. Why, ma'am? Because this can do the resonance. The resonance stabilizes that, then this position. Okay. So the first product formed would be, that will be having Cl and then remember the same. The second reagent, that is N-bromosuccinide. What that guy will do? Simple, bromo group will get substituted over there. Where that will get substituted? Here I am having only one position left. Once again, right? So that is more stable intermediate. So the product will become like this. Correct? So PR will get added over here, right? Then this is our B, this is our A and C. They are asking for C, isn't it? So KOH 1 mole. They just mentioned 1 mole only. So what KOH will do? It's a alcoholic KOH with heat. So which will do the elimination part. They also mentioned 1 mole. 1 mole means only one eliminated product it can form. Either Cl will go or Br. Taking the hydrogen. So if Cl is going, if Cl is removed, then it should form a product which is an alkene. It can be of terminal alkene, right? It won't disturb the stability of the aromatic ring. So it should lead to the formation of terminal alkene, which is comparatively not good product if I am comparing the bromine case. So if bromine is leaving the compound, it will lead to the product like this. So which can undergo the substitution, resonance. Okay, so this is our C. So this is the question. So let's see the options as well, which will suit our answer. So option A, which suits that option answer we have, which makes it the correct answer. Moving on to the next question. Correct statement for the products of the following reaction. This is MSQ type, more than one right answer. Here you go, Cl2 at 500 degrees Celsius. The options are pretty different from JEE Main, isn't it? 4 different products are formed, 2 optically active products are formed. The optically active compound formed here can also be made by the reaction of HCl, and the reaction path is free radical substitution. Obviously, this is free radical substitution that we know. So option D is right. What about other options? For that, we have to do the reaction. So let's proceed with the reaction. We have the reactant CH2 double bond CH, CH2, pH, right? So which radical would be much more stable? We found that is undergoing free radical substitution. So which would be addition? Actually Cl2 is there, which would be stable. Let's say if the free radical is formed over this carbon, and if the free radical is formed on, let me write the product for the first one now. The free radical is CH2, CH radical, so that it can undergo the resonance. That's what the main purpose is. Okay, so that free radical, or else there is another option of formation of CH2 radical, CH2, sorry, double bond here. So this will also give the better resonance, right? Resonance wise more stabilized. So these two are more stable free radicals. So let's substitute the Cl over here. So let's see what happens. So by substituting Cl2, the Cl radical over here, then the product will look like CH2, Cl, CH double bond CH, PH, right? Similarly, Cl radical, CH2 double bond CH, CHCl, PH, right? So the question involves optically active, how many optically active products are formed and how many different products it can form. So as of now 2, but what about the isomers? So you can see here I am having the chiral center, right? So this can give 2 optically active enantiomers, right? Okay, so what about this guy? So this is having one side H, another side PH, one side H, another side CH2Cl. So which makes it can exhibit 2 geometrical isomerism, right? So which makes option A is right. Optically active products are 2 optically active products are there. Yes, that is also right. What about C? The optically active compound formed here can also be made by the reaction of HCl. So let's check. So here I am having this. So if I am adding HCl in the reactant, will that be forming over there? The same kind of product, can it be formed? So for adding HCl, first H plus should go and attack. So which should be more stable? Obviously CH3, CH, once it is attacked, CH plus CH2 PH. Now you have to look one thing, that is there any chance of doing the rearrangement? So whenever you are finding any carbocation, whenever you are finding any stability matters, so in that case you have to look upon the ring formation, or any rearrangement can happen over there to make it much more stable. So that knowledge will be checked in your JEE Advanced examination. Okay, so here you can see the hydride shift works better. Why? Because you can see this carbon would be much more stable. I'm not mentioning it for optically active. This carbon is much more stable because of pH resonance. Okay, so that's why CH3, CH2, CH, PH, this will be much more stable. Then Cl minus will come and attack. The product will be CH2, CH, Cl, PH will be formed. So is it similar to this compound? No, obviously no. Here I am having a double bond, there we don't have. So option C is the wrong one. A, B and D are the correct options. Okay, clear? The reaction is very simple, but you have to know the concept that matters. Okay, so this is our next question. Compare the properties of two isomeric products X and Y formed in the following reaction. So the reaction is so simple. Reaction is so simple where I am having phenol with CCl4 KOH. What is this reaction? Trimer, right? It's not trimer, guys. It's a variant of that. I would say it's a variant of trimer. Because trimer we use CHCl3 chloroform to form salicylaldehyde. Right, ortho and para substituted product. Here I am having CCl4. Then what would be our product? Salicylic acid is our product. Okay. So ortho and para substituted salicylaldehyde. Sorry, salicylic acid. Okay. So the option says to compare the acidic strength, solubility, volatility and melting point. X and Y are the compounds formed. Ma'am, which should be X and which should be Y? So let's take it out. Let me take ortho as a X and para as a my Y. So in ortho product, there is a stability over here. The extra stability is because of the intramolecular hydrogen bonding. It is very important. Okay. So this hydrogen bonding is responsible to make it much more stable, right? And make it besides the acidic property, besides the solubility, volatility, right? So which makes it much more acidic. This is more acidic. So if I am taking X is more acidic, what are the options I can eliminate? So if I am taking X as more acidic, so option A and C are eliminated. Okay. Then they are asking for H2O solubility. So I already told you, we already discussed in mock test 1, if there is a hydrogen bond, the solubility will decrease. So X will have less solubility when compared to Y. So X will have less solubility than compared to Y. Okay. Volatility. So if I am talking about volatility, this is ortho product is always stay volatile. So this is having X is having more volatility than our Y, right? So volatility is also high. Then they are talking about melting point. So melting point is decided by the parking efficiency, right? So X is unsymmetric when we are compared to Y. So which makes the melting point is, the options are very bit clumsy, but the option, this is not right. The melting point of X is low than Y. Okay. So which makes option D as your right answer. So what if I am taking Y as your salicylaldehyde or ortho substituted one and X as your para substituted one, then you will also get option D as your right answer. I am leaving it to you. You can just fix it. You can just fix and try it with these options. Okay. Clear? So moving on to the next question. Next question is asking for the product E. Okay. So the very simple one. Let me do it here. So CH3MgBr with this, it is forming A. So let me erase, or let me write it over here. So CH3MgBr. What tritinoid reagent will do? I Always I'm telling you, if I'm having a double bond O, then this oxygen will have a hydrogen, and whatever the R group the grignard is having, that will get attached to that carbon, that carbonyl carbon. As simple as that. Okay, so you need not to waste your time to writing all those arrow marks and mechanism. So just I'm having OH over here, CH3. That's our A. Then HBr. HBr, what that will do, if that is having an alkene, then that will undergo addition reaction of Markovnikov or anti-Markovnikov. If that isn't, there is no alkene, then it will go to substitution. So OH will get substituted by our Br. As simple as that. See, JEE Advanced is not easy, but at the same time it's not difficult at all, particularly chemistry part. Most of the students will omit chemistry just because they'll not omit at the time of examination, but they'll omit at the time of revision. I don't know why. Chemistry will give you more marks than you expected. Because you already read everything in JEE Main. You aced the JEE Main. So you can expect more marks in JEE Advanced if you are good at chemistry. Okay, that will increase your rank as well. Okay, so Br will get substituted over here. Then B with the magnesium ether. So what that will do, magnesium will take up this position. That's it. As simple as that. So I'm writing CH3 MgBr. That is our C. Then D. Here comes, I already told you, write it like this. C double bond O H H. Like Grignard reagent, what that will do with carbonyl compound? What that will do with carbonyl compound? Here I'm having a Grignard reagent like this. So the whole R part will get substituted on this particular carbon. So C, remaining thing I'm writing over here. This is having OH, and this part both the side I'm having hydrogens, right? So remaining CH3 is there in the Grignard reagent. We check. MgBr, just MgBr. Sorry guys, I just made a mistake. MgBr and this side CH3. Okay. So it just got added over here. Okay. So this is our D. Then D with HI, isn't it? D with HI, that is producing E. So now it's time to check the options. Here I'm having two different products. One is 5-membered ring, another one is 6-membered ring. Let's check whether if that is forming a 6-membered ring, that would be stable or not. Okay, so HI, what that will do? That will obviously get substituted, right? So in that case, if that is a tertiary carbocation, then that would be much more stable than this primary one, isn't it? So which makes the ring expansion. So ring expansion of this true, so that 6-membered ring is formed. Here I am having CH3, that position become vacant, plus so the I minus will come and attack over there. So 6-membered ring, which CH3 and I. So that is my answer. Let's check. Yes. So here I'm having option D, 6-membered ring, CH3 and I. Okay. So very simple, but you need to know what should be applied. Okay. So this question I particularly chose because these reagents most of us don't know. So this question, this type of reagent is never asked in JEE Main. Okay. So you don't know about this type of reagents. I would recommend you to leave the question. If you're not sure, if you're not at all know the reagent, please don't waste your time on that particular question. Okay, skip and go to next question. You can come back later and do that, but you should have enough time to do the questions you already know, right? So let's see this question also, because you won't skip this part if that is coming to your examination this time. Okay, let's check it out. So this is what happened over there. I just presented the mechanism. Let me explain it to you. We took the reagent ammonium carbonate. It is producing A, then CCl3COO Na, that is giving B. They are asking for the B. Okay. So ammonium carbonate, what that will do? That will do the nucleophilic addition reaction. Okay, so that will undergo nucleophilic addition reaction of having NH3. Let's see. First, H plus will come and attack. So that OH has been formed, and the lone pair of nitrogen will attack the carbon formed over here, right? Then the oxygen lone pair will take up the hydrogen to make it much more stabilized. As a next step, the ring formation will happen. Here you can see 2 carbons over here. So totally 2, 3, 4, 5. 5-membered ring must have been formed. Fourth and first position I should have CH3. Right? Like this. 5-membered ring. Fourth and first position I am having CH3 and OH. OH. So this is our first position. So OH. Then H plus will come there and take up by heat. Heat is given in the reaction rate. Yes, heat. It will lose the water. It will lose 2 moles of water from here, so that it will form A. The reaction won't stop here. They are asking for the B. So B starts here from dichlorocarbene. This is carbene, right? So first H plus is left a compound. N minus is there. So here you can see, as usual, what we saw in the Riemann table also. It is forming a carbene intermediate. And then this is forming another cycle over here. But to make it much more stable, the cycle will break. This carbon leaves the compound. This goes here. Due to that, this breaks and goes here. So let me count the carbon and nitrogen in the ring. So from nitrogen, 1, 2, 3, 4, this bond got broke. So 5, 6. So 6-membered ring, 6th position, I should have 6. So 6th position, I should have a methyl group, right? And 2nd position, I should have methyl ring, methyl group. Then 3 double bonds because of this. And because of this minus, and already I am having a double bond, and the 5th position should have a 1 Cl. Okay, now it just formed a stable product. B. So they are asking for B. So let me check the options as well. Here you have yes, not B, C or D. Answer to this question is option A. Okay. So moving on to the next question. Hope this is clear. I already told you what you will do in these type of questions. Okay. Next question is very simple, guys. You can easily do that. Right. So I'm having a benzene ring. Not a benzene ring actually. Isn't it? Not a benzene ring. So I'm having two rings. I'm just having two rings and then 4 cyano group. So what is the reaction happening over there is it is just doing a hydrolysis. What will happen if it is undergoing hydrolysis? Cyano group with hydrolysis, it will become carboxylic acid. Isn't it? Carboxylic acid. Is it much more stable? The two carboxylic acid group on the same carbon? Not at all stable, right? So what that will do? That will go as CO2. It's 2 CO2 because I'm having 4 carboxylic acid group. So it will form carboxylic dicarboxylic acid. Okay. So still I'm having a heat. So upon heating, it will become anhydride. Correct? So C double bond O, O, double bond O. Right? So this is my product. Let's check with the options. What I have over here. Here I'm not having double bond. Here I'm having the double bond in wrong position. Option C, it's not good. And option D is my answer. Clear? Moving on to the next question. This question is very simple question if you could see that. But they are asking it with isotope. Okay. The options are what is X and Y? That is my question. So let's see about X. Carboxylic acid, benzoic acid I have treating with ND3. Instead of hydrogen, I'm having deuterium, isotope of hydrogen, ND3 and heat. Then as the next step, KOHBr2. What is this reaction? If you know what is this reaction, what is this reagent is used for, let me know in the comments. I will give you as a reward of mock test question paper with solution. Okay, then H2O, that is producing X. Similarly on the other side, NH3 with heat, KOD, instead of hydrogen I'm having deuterium. In the next second step, Br2 and D2O. Okay, heavy water I just used. So what would be X and Y? That is our question. Okay, so let's see. So let me take benzoic acid. X, I'm finding it out. NH3 with heat, right? So NH3 heat, that will form amide, isn't it? NO, CO, NH2. Then as the next step, I'm having KOD, Br. Correct? So in this step, it will form amide to amine. This is very famous reaction, guys. But the twist over here is how it is forming amide. Sorry, amine. We know that it will form amine, but with deuterium or not. So that is our question. So with deuterium, so there is a step, there is a mechanism in this particular reaction that will undergo a step like this. Okay, so after that it will form our amine with our H2O. Okay, I'm doing for a Y. Okay, so D2O. So which will need to form instead of H I'm having D. So it would be ND2. Okay, so this is my Y. What about X? So once again I'm taking benzoic acid with ND3 heat, so which will form ND2, sorry, COND2 amide, then KOH Br2. I told you this mechanism, particular mechanism that will lead to the formation of NC double bond O first, and then followed by base and H2O. It will give you NH2. Okay, so this mechanism part you need to know. Advanced is a lot more about mechanism and the route, the rearrangement it is taking. So that is how they can check your knowledge, isn't it? So this is my X and this is Y. So let's check out with the option, not C, not D. What about A and B? X is ND2. X is NH2. Y is ND2. Option A is the right answer to this question. Clear? So moving on to the next question. The major product of this following. So it's just a Br2 is adding over here. Here I'm having a double bond. Can you see that? Here I'm having a double bond. Br2 will add. So what Br2 will do? Anti-addition that will undergo, and first of all that will form a intermediate, right? It will form bromonium ion intermediate. Correct. So once it is breaking, once brominium, it is not at all stable, right? So what that will do? Obviously, our lone pair of nitrogen will attack on one position to split this ring. Here I am having 8 including nitrogen, right? So you can check 1, 2, 3, 4, 5, 6, 7, 8. So let's check out the options. So we already know, that will undergo the split. So this can't be our answer. And what about this? So here I'm having 1, 2, 3, 4, 5, 6, 7, 8. Okay, this can be our answer. Let's check out the other options as well. 1, 2, 3, 4, 5, 6, 7, 8, 9 is there. So this can't be our answer. Then obviously D can't be our answer. If you know that will do the stabilization part by splitting this ring, you can take option as answer as option B. Okay, so this is what happens over here. The ring will get split up and then the hydrogen will get added over there. That's it. Okay, moving on to the next question. Here we have the final product of the reaction shown below on polymerization would produce. Okay, once we found out the final product, it will undergo the polymerization process to produce which one? PVC, chlorofluorine, neophluorine or rubber? Okay, so rubber obviously not, because that is not having any chloro group. Either ABC, polyvinyl chloride, chloropyrene or neoprene. So chloropyrene is one of those monomer, right? So either option A or C would be our answer. Let's check. So let's see what we have. CuCl with ammonium chloride. So you know that will obviously metal with this kind of acidic substance. It will form Cu first and then after that it will give you triple bond C, CH, double bond CH2, isn't it? So after that it is undergoing the reaction with HCl to produce it will get added up over here. So CH2 double bond CCl CH double bond CH2. Cool. So now 1, 2, 3, 4. Okay. So now it is undergoing polymerization. Would produce what? So this is our chlorophyrin. It is undergoing polymerization. What that will produce? It will create a polymer of like this, right? So which is our neophrin. So option C is your right answer. PVC, vinyl chloride is my monomer of PVC, right? So which can't be our answer? Neophrin is my answer. So this question, among the following compounds shown below, the compound which yields the different product on the reaction with warm HNO3. So warm HNO3, what does it do? It is a very good oxidizing agent, right? So what that will do? So what that will do, this will do the oxidation. So CH4 becomes COOH, CH2OH becomes COOH. In option B, I am having CH4, that will become COOH. CH3, it will not get disturbed. And option D, COOH. Here also COOH. D is not our concern. So, as you can see, option A and C are pretty much same product if you are undergoing the rotation. Okay, it may be look different, but if you are doing the rotation, it will look like same. Okay, so only the option B is looking different. It will yield the different product on the reaction with warm HNO3. So option B is our right answer. So moving on to the next question. Above compounds can be differentiated by using the reagent. So here I am having phenol kind of compound and then OCH3 and OH. So options are NaOH tolerance reagent and FeCl3. So FeCl3 works for phenol. It will give you the purple. So it is there in all four options. Okay. Our only concern is tolerance reagent should come first or second. We should find the order also, right? So tolerance reagent, which will give you positive for this compound because it will change that to aldehyde, right? So it will oxidize it, it will give you positive for tolerance reagent. What about NaOH? That will not give. And the Na, it is not possible. Talking about chromic oxide. Chromic oxide is a mild oxidizing agent. So it is an oxidizing agent. Right. So in that case, let's say first I am adding chromic oxide. First I am adding chromic oxide so that C1, the last one, will get oxidized to CHO1 out. Remaining 2 I have. Next I am adding tolerance reagent. So tolerance reagent will give positive for option C, compound C. Again that is out. Remaining I am having A and B. So among A and B, Nucleophilic proline will give you positive for A compound. Right. So in that case, A can be differentiated from B. So you can go by B, not by C. Okay. That would be more suitable for differentiating these compounds. So clear? Okay. So that's it for today. Practice more and more questions. Let me know any mock test paper, any physical chemistry chapter or any physical chemistry or inorganic chemistry questions you want, or do you want more practice or organic? Let me know in the comments. Okay, and don't forget to mention what is the reagent and what is the name of the reaction. I just mentioned earlier, asked you to put earlier. I will give you the mock test paper. Okay, cool. Practice more questions. Thank you.